topic here in the pub sub, right? What will happen? It will simply create, right? As soon as you create the pub sub topic, it will create a default subscription as well, right? So I created this topic, SnowPy pub sub topic. So for the same, it has created a default. Once you create the topic here in the pub sub, right? What will happen? It will simply create, right? As soon as you create the pub sub topic, it will create a default subscription as well, right? So I created this topic, SnowPy pub sub topic. So for the same, it has created a default subscription, and we already looked at it during the Kafka, right? So if you want to consume the data from the GCP PubSub topic, you always need to use this subscription, right? You basically need to use this subscription ID to do that. Okay. So we have created this thing. Our subscription is created. So let's see how we are going to set up this entire, let's say, notification integration part. So create or replace notification integration, this thing. Type equals to Q, notification provider equals to this one, enable true, GCP PubSub subscription name. This is the part we need to provide here. So how you can get the PubSub subscription name? Very simple. So this is the subscription we have created. So let's click on this one. Correct. And this is the subscription name. You can see here. So just copy this part entirely. Just copy this part, subscription name, and just copy it here. That's it. And after this one, you can simply create the particular notification integration. And just like storage integration, your notification integration is also the secured configuration. You are basically trying to create the access configuration. So as soon as you create this thing, right, again, using the describe integration command, you can get the details of this particular notification integration we have created. So the way we try to give permission and whitelist the, you can say we try to whitelist the service account with the particular permissions. In the same way, as soon as we created the notification integration and we describe this thing, right? If I execute it, so here you will see GCP PubSub service account, right? So GCP PubSub service account has been created. Now what we can do, we can simply register this service account on the GCP side. So in that way, the service account which has been created here is whitelisted in my GCP account. So this connectivity of PubSub with Snowflake will be set up in that way. If we are adding and whitelisting this service account on the GCP and giving the relevant permissions to consume the data, right? Then the actual connectivity set up between the Snowflake and PubSub. So whatever notification will be sent by, whatever notification will be sent by this particular, you can say, whatever notification will be sent as soon as we land a object in the storage bucket, notification will be sent to the PubSub and the Snowflake will be able to consume it. Okay, so let's look at that part, how we are going to achieve it and how we are going to do that. So this is the service account which has been created, correct? So let's come to this part, data for Snowpipe and nothing here. So this is the new service account which has been created for the notification integration. So let's come to our IAM and admin. So here and the roles part, right? So first thing first, what you need to do in order to whitelist the service account for the PubSub notification integration, you need one custom role, right? You need one custom role regarding this thing, the PubSub matrices, right? You need one custom role which you can integrate with this particular service account for the right permissions. So focus here and let me tell you that what is that next custom role we are going to create. Since you already know that how we have created this one, the previous one, let's say related to the storage integration. So look at this part, right? I have created this thing, pub sub monitoring role. So this is also a custom role. So I will simply show you that which role you have to create. You can create a role with this name and now you know that how to add and assign a permission. So simply you can do this thing. If I come to the edit role part, right? So I created this custom role. So let it load. So here you can see PubSub monitoring role and this part. So here you simply need to search for this particular permission. Monitoring.timeseries.list means the point is very simple here for the Snowpipe to get the data from the PubSub topics using the subscriber. Continuously it need to monitor, right, the number of messages, right, and all those matrices. It needs that information so that it can poll it and it can get the data as soon as they are, let's say, arriving it, or maybe with some lag. So that is why we have created this custom role, PubSub monitoring role, and this permission, monitoring.timeseries.list. So do that and simply create this particular custom role. So after creating this notification integration and after getting the detail of the service account for the GCP PubSub, the next step which you had to do, that was to create a custom role for PubSub monitoring with this particular permission. And the next thing, to create or to whitelist that service account here. So how you can do that? You can simply copy this service account, copy it. You are inside the IAM, okay, and here you can go to the this part, service accounts. Sorry, not here. You can come to the IAM part here, and here you can see this thing, grant access. So click on the grant access. So that was the new principle. This was the new principle basically for the PubSub notification integration. It has been created here. So you need to attach this custom role which we created, PubSub monitoring role. Also, this service account need a permission of the subscriber, because using this service account, Snowflake is going to consume the messages from the GCP topic. So PubSub monitoring role, that is what we have attached here. Now another role which it needs here, that is PubSub subscriber, or you can simply search for this one, subscriber. Okay, so this one, PubSub subscriber, not the PubSub Lite or anything. PubSub subscriber, this is the role you need. So this was the service account for the PubSub notification integration. You created a custom role, you attach that one, and then you are also adding the PubSub subscriber role. Do this thing and click on the save part. And in that way, the way I have registered or whitelisted this one, you can see here, this was the one I whitelisted already, this particular one, and basically granted all these permissions and the roles. And this is how the service account created for the notification integration is whitelisted with the right permissions. So for the quick summary, what we did, we created the storage integration, and after that we fetched the information of the service account created by the storage integration. Then we whitelisted that particular service account on the bucket, and we provided the relevant permissions to that particular service account for the storage integration. Next thing, we created a PubSub topic, and then we created the notification integration, and then we fetched the service account information for the notification integration. And after that, we created a custom role for the monitoring, and we whitelisted this service account created for the notification on the GCP account, and we added those permissions. One was the PubSub subscriber and one the custom role we created. So this is the thing we have done so far. One thing is still missing. We have still not set up the notification part, right? So far, if you look at it, Snowflake is able to connect with the Google storage location. Snowflake is able to connect with the PubSub. But how this particular, you can say PubSub is going to get the notification from the bucket. We have not set up that part yet. Okay. So for that one, we can simply do it from the you can say we can simply do it from here, from the GCP shell itself. So here what you can do, you can open this shell. You can simply go to GCP. You can open this shell, or if you have the gcloud CLI already installed, so you can do it from your local terminal itself. But let's say if you haven't installed it, you can simply do it from here. So click on this GCP shell, just like the terminal. So as soon as you start it, so maybe in your GCP account, you can have multiple projects, right? So since in our GCP account, we have only one project. So by default, this shell is attached for the project which we have here, right? So whatever the commands we are going to run, so they will be getting executed inside this project itself. And you can see it's already attached. Okay. So what we need to do, let me zoom in my screen. So after opening your shell, basically you need to run this thing, right? You need to run this Google Storage Utility command. So this is basically the CLI command. So gsutil notification create. So this is what we are doing here. Look at this example. The create notification -t means on which particular topic. So this was the topic we created, and -f means the JSON, right? In which format the notification will be created, JSON. And what is that bucket from which as soon as the objects are getting created, right? So as soon as it is being done, the notification will be received by the PubSub topic, and in that way, Snowflake will be able to get that information and will be able to complete that load part. So gsutil notification create -t on which particular topic, -f means which format, JSON format, and the particular bucket we have created, right? So that is how you will be able to do it. Just hit the enter and it will create the notification between the PubSub topic and the Google storage bucket. So once you do this thing, then the part of connectivity, receiving the notification, this and that, you are done with that particular setup. Now the only thing which is left to create the snow pipe and enable that. And as soon as you do it and you start uploading the files in the storage location, you will see that the snow pipe has started receiving those files and will start loading that thing. Okay. So let's come to this here. Storage integration was created. And now this is the part you can see here. Okay. So we are now simply creating the snow pipe. So create or replace pipe. This is the pipe name. Auto ingest equals to true. So there are two things, like you can enable the auto ingestion, means as soon as the file has arrived, it will complete the ingestion, or you can disable it and you can create the tasks and schedule it. So there is no concept of the workflow management exactly, right? As of now, it may be in the enterprise accounts, but the way we were doing the workflow management in the Databricks, right, and creating the dependencies and all that, from that front on the UI side, it is not there, but you can do it by the declarative statements. You can create the different tasks. So a task could be related to creating a table, or it could be to run the copy command after every 1 hour, or to refresh a materialized view every day based on the cron expression. So all those things we can do with the help of task and the task scheduling, and we will look at it as well after this Snowpipe thing. So here we have enabled the auto ingestion, means it will be a simply infinite running process in the backend, and as soon as notification is received based on the metadata, it will get the file name and will load the content of that file in the Snowflake table. So here auto ingest equals to true. Integration. So here we are using the notification integration so that the notifications can be revved from that particular PubSub topic as, right, how this pipe is going to run and what is the, you can say, definition of this pipe. So the definition of this pipe is very simple. Copy into this particular Snowflake table from the external stage, which we are referring from @snowpipe stage, file format type equals to CSV, right? So this is like the definition, because this could be a whatever pipe you are creating, maybe the pipe is something which is doing the join operations as well onto two different tables, and then whatever kind of output you have, that you want to ingest into some target table. So here it is all about the ingestion. So you will be writing the copy command. So copy command means loading the data from that external file path to the Snowflake table. So that is what we are doing. So create and replace this Snowpipe, auto ingestion is enabled. So for the auto ingestion to be enabled, from where it is going to get the metadata information, like from where it is going to get the trigger. So this notification integration we have created, the message inside that one is a trigger for the pipe to load the data. Then how and what we are doing inside this pipe. So in this pipe, this is what we are doing. Copy into orders data landing zone from this external stage. So every time a new object is getting uploaded there, this external stage is going to point that new object based on the notification integration metadata we are getting. File format type equals to CSV, and other properties as well if you want to provide. So the way the properties were defined when we were loading the data from the UI, in the same way we can provide here, and in that way it will get loaded. So this is our pipe definition. As soon as you create it, there could be multiple pipes as well, right? So here you can see pipes. So this is already created. So let me click on this one. Okay. So here you can see this is the pipe we have created, and all the definition, the owner and the metadata related details are published here. So we can look at it. And let's say, so as I said, pipe is what? Pipe is basically your infinite running process. Okay. So in this case, if you want to check the status, so here you can get the flexibility to change the status, change the execution of a Snowpipe. You can pause it if it is not needed. You can delete it. You can again start it. Okay. So basically to check the status of a particular Snowpipe, you can use this system table, and you can use this procedure pipe status, and you can pass the Snowpipe name, which is this one, and you will get the status. So let's run it and show you the status. So here you can see execution status is in the paused state. Okay, it is in the paused state. So what we will do, and before that, let's see what kind of data we have in our landing table. So how many records? So in total we have most probably 7 records or something, right? So we have 7 records, and we will be uploading more files there, and we will try to see. But before that, what we need to do, we need to start this thing, right? We need to start the Snowpipe so that we can again start it. If it is not started, auto ingestion will not happen because we have already seen it. And this is how you can basically stop and you can pause a particular snow pipe. So you can run the alter pipe command. So alter pipe, this is the pipe we created. Set pipe execution equals to paused equals to true. So when this is enabled means your pipeline is in the hibernate state or it is in the pause state. And now you can again just enable it and you can restart it. Okay. So for that one, you can simply do this thing. Pause. Uh, Pipe. Just a second. Start. There was a different syntax for that. So here pipe execution paused is true. So it has paused it. So pipe execution start. I think we need to use that one. And maybe, yes, we can do it in this way as well. So alter pipe. This is the pipe name and we can basically do this thing. Okay, so let's run it. It should start our pipe. Hmm. Hmm. Pipe execution. This should start the pipe. Pause. Let's look at the status. Okay, now it is in the running state. This is not needed. So with the pipe execution, pause, like if you set it up like true and false, based on that one it will work. I thought there was a separate command, so I was checking for that. But with this one itself, it is working. So pipe execution paused. If it is true, your pipe will be in the stop state or the pause state. If it is false, you can see execution state is running. And how we are checking the status? We are simply checking the status with this one. Okay. And now here, if you look at this part, right? If you look at this snow pipe which we have created, it is running the copy into command, right? So based on the system table information, right? Based on the system table information, if we want to get some information, but even before that, if you look at the status part, right? I would like to show you some metadata information here. So when we are running this query to get the status of the particular snow pipe, if I copy this information, right? I selected this one. Let me copy and show you this information here. One second. Let me put it some formatter. Okay. So execution state running pending file count. So here you can see when you are running your snow pipe auto ingestion is enabled. So since there is no new message for it to consume, so pending file count, you can see 0, last ingested timestamp and last ingested file path, right? So you can see it is gathering all that information and when you are running or you are trying to check the status of the particular snow pipe, it is giving you all that information like when it received the last message, when it forwarded the message from which particular channel, right? It pulled it forward file path, right? So this is how it is working, and based on that one, all that ingestion is happening. You try to like keep on uploading new files in that location based on the PubSub notification and all that you have set up. So Snowpipe is automatically dealing with those information and running your ingestion. Okay. Similarly, so if we are interested into this thing, because within this particular table, right? This is our target Snowflake table, right? So if we want to see the history of copy command, right? Means if you look at the definition of the Snowpipe, right? Ultimately, we are running the copy into this target Snowflake table, correct? So by any chance, if we are running this thing, right? By any chance, if we are trying to see the history of copy commands which have been executed on this particular table, so that will also help us to understand whether the ingestion is happening properly or not. If I have uploaded a new file, so whether it has been ingested or not. So if I simply run this system table command, okay, so date, address, order, table, information, schema, copy, history. Orders, data, landing zone. Okay. Orders, data, landing zone, start time, date, add hours. Oh yeah, like this is more about like ingestion in the last 1 hour. So once we will, so here what we are doing, information is schema, copy history, start time, and the end time. So we are basically trying to check in the last 1 hour. So hours, comma -1 in last 1 hour, how many times this copy into command has been executed on this target table. So let's try to upload some file in this location, right? In this location, and try to see whether the Snowpipe is working fine or not, right? So if you look at the last ingestion was done for this particular file which I loaded here, it was this one. So I'm going to upload same file maybe with a new name so that we can distinguish for the time being whether it has picked the new file or not. And also I will open this thing, right? So here, this is the subscription which we created. So as soon as some message will be published into the PubSub topic, and our Snowpipe is consuming that information from the subscription. So we will see some spikes here for message arrival and all that, and then we will see Snowpipe is picking up that one and running it. Okay. So let me quickly copy this file here. Let's say save. Yes. So let me copy this file and let me create a new file here quickly. New file, orders 2024 12, and okay, let me paste the data here. 7, let's say 8, 9, 10, 11. Okay, that kind of information, and let me save it. And what I'm going to do, I'm going to upload this one. And once we do that, then like it will clarify everything that how it is working, the event driven processing part at the end. So let it upload. There might be some like time lag here, the way PubSub subscriber is going to consume it, and those messages are going to reflect, and based on that one, Snowpipe will consume the information. So if we come here and if we look at the status, right? So currently, let's see what is the status of the Snowpipe. So still you can see pending file count is 0, and the last ingested time, this is was the file, right? This is the file. Let me put it here. This is the file, right? It processed last. So if you will come here, you will see that the message. As soon as you will see some spikes here, that means then Snowpipe has consumed the messages. So as I said, there could be some lag. And let's see again here. Still not yet. Okay, so let's give it a moment here to reflect. It's coming here. Let's try to see. Some time for the initial messages takes some time. That's from the pub sub type, not from the Snowpipe, because as soon as Snowpipe sees something, it instantly start working. No message yet. As of now. Meanwhile, let me prepare one more file. Just a moment. Orders 2024, 12, 29, CSV, say 12, 13. Okay, so yeah, let's come here. Where is that message? This is the lag on the consumption side. So publish message count, some spike is here. Okay, so we might expect it in a moment. So there you can see, right? Unpacked message, this one. So yeah, it took some time due to the lag. And now maybe if I run it, and we'll be able to see it. Okay. So now again, pending file count is 0. So last ingested file, as you can see here, this one, right, which we uploaded. And we will also try to see the copy history command on the target table. So here you can see file name was this one, stage location, last load time, row count, and all that. So this is the information we are getting from the, you can say, sorry, where is that one? Yep. So this is information we are getting from the system table. And also let's again list, right? We have the stage, so list of stage, so you can see here for this one, right? So that is how the you can say data is there and the automatic pipe is running. And 7, 8, 9, 10, 11, let me quickly upload the second one as well, because maybe first for the first uh, message consumption it may be in a lag, but not for the second. It should happen quickly. So we have now uploaded this one, and let's quickly come here. Let's look at the spike. If all your integrations and everything will be proper, right? So it will run fine. So no second message as of now. Let's see. So let me check in the status. So in the status, yeah, you can see as soon as I uploaded it, it has instantly processed it, because here on the these aggregation matrices, right, are being you can say these matrices are being pulled. These matrices are updated with some lag, and that is the reason. And since it listens to those matrices, right, so that is the reason with some lag. And now, right, first message was here. You can see one more spike, right, is there, which was for the second message. So it's based on that one. It is just like getting all that files you are uploading, and based on that one, it is simply doing all that data ingestion part, right? So it is more about setting up a snow pipe. And so now here we have two things to understand, right? Your question could be, if we have Spark, if we have this and that, then why we are bringing these type of things into the picture where we cannot get so much of control, right? It would be much better to like do it via Spark and all that. And that is totally like your thought is totally fine. And usually when you talk about the patterns of the development, this is how you will see it, right? And mostly when you talk about consuming the data and then cleaning, cleansing, and all that. So you will be bringing Spark into the picture, and after processing it, you will be dumping into the target Snowflake table. Okay. But here, let's say when you want to achieve all these things on the Snowflake side itself, obviously, when you start doing it, when you start doing it with this thing, right? Just with the SQLs, then things will not be that much in the control sometime, right? Like processing, optimizing, tuning, and all that part. So data warehouses are meant for your final transformed data, which you want to keep there, and you want to perform the analytical queries, right? In a quick span of time with the parallel processing and all that. So when you talk about these production architectures, you will be having the Spark pipeline before that one, whether it can read the data from the Snowflake table and maybe writing the finally transformed data, cleaned data, and all that into the Snowflake tables. But here it is all about taking care of the ingestion, right? If let's say for this simple task itself, or where it is all about the simple data ingestion without any complex transformation and all that. So just for the centralized integration, just for the centralized processing, it can be done with the Snow pipe itself. There was, if you do not do it, let's say with the Snow flake component, then you have to maintain things related to Spark, and you have to maintain things related to the Snow flake. But here you are managing all those things here, right? As I said, we will also look into the task, how we can schedule the task, how we can create it. So based on that one, you can try to set up some type of lineage. You can get the control till some extent, and you are able to achieve your raw data type of ingestion. Maybe there is some client, some other team whom you are working with, they are giving you some intermediate processed data, and you want to just maybe query that, you want to process it, you want to have it in your internal Snowflake warehouse. So you can basically set up these kind of snow pipes which can auto refresh them, and manually you can trigger them, manually you can run these pipes to do certain things, right? And maybe continuously running process. So for that reason, we are going to have it rest. As I said, for production grade scenarios, you will see all the heavy lifting work most of the time being done on the Spark side itself for that better control, for better tuning performances and all that. And once we have that intermediate transformed data or the transformed data, or maybe you are following the medallion architecture for the silver gold layer, you can have those things here. You can build your dimension factor tables. You can set up your entire, let's say, data warehouse, and setting up the connectivity between those dimension and factor tables. And accordingly, you can answer the business insights. You can run the queries on top of it. So but here we are looking into the Snowflake, so it's important to know that how these snow pipes are working. You can basically run a specific SQL sheet. You can run a particular Python sheet from a task, right? You can schedule a task to do certain jobs. So this is how it is going to work. And related to those things, right, which I'm talking about, how to do it. So that's definitely we will look at tomorrow based on the projects, dedicated projects we will be doing onto those sites, right? Working on the medallion type of architecture and setting up the, let's say, warehouse for some tables, right? For creating the fact table, creating the dimension tables, and all those things we'll be doing tomorrow with the project. But here we need to touch upon these components, how they are working, right? Like the snow pipe, how this entire event-driven architecture on the Snowflake we can create end to end. So the next thing we will look quickly, that is the task scheduling, how we can create the task. Since you already know the merge queries and all that, it will hardly take 5 to 10 minutes just to explain the task and how you can set up the lineage and all that. So once you will try to look at the task and the task scheduling on Snowflake, right, you will feel that we need the better orchestration. And that is the point I want to make here. Whatever we are learning, be it the airflow, be it any other things, so from there you can get a better orchestration control rather than utilizing these native task scheduling and all that, because here a lot of things cannot be achieved, right? There will be limitations, and that is the part where we will try to orchestrate most of the things from the airflow, let's say. But here, let's say there could be some necessary task for that one. There is no need to write the airflow job and all. So for example, you have 3 4 materialized views which you want to refresh every day at, let's say, 10 p.m. 10 p.m. In the night. So you can simply create a task, you can schedule it based on some cron expression, and based on that timing frequency, it will get triggered automatically at 10 p.m. and will refresh your materialized view. So there was no need for anything. But let's say there could be a reason where you want to set up some dependency as well, right? First, this materialized view should get refreshed, then this next materialized view should get refreshed. So you can set up that dependency. If the top one is failing, the upstream is failing, the next one will not get triggered. So these kind of things can be done and we can achieve that once. So let me disable this thing, the pipe, and then let's quickly take a 2 minute of break, and then we will just wrap up the task scheduling part and we'll be done for the day. Okay, so let's quickly meet after 2 3 minutes. All right. Cool. So let's quickly look at the scheduling part, like how we create the tasks and how we can set up the dependency between them. So here I'll try to demonstrate it with some mock table and the mock data and how that is getting refreshed. And you already know the merge queries. So kind of merge queries I'm going to use here while showing like how we are creating the different tasks and how they are getting scheduled. So with the help of task, right, any sort of thing you can basically control specifically in terms of the triggers and execution. So for an example, these pipes and all that. So here, let's say if we wanted to control it manually, we did not want to run these things like as soon as files are delivered and all that. We wanted to run it if uh, we wanted to run it after every 2 hour, 3 hour, 4 hour. So we can basically schedule our pipes execution via task. We can write any custom query logic which is refreshing based on which we are simply refreshing our materialized view, and maybe we can schedule some create a table drop table kind of commands as well. We can set up that entire lineage and dependencies or between different steps we want to like perform throughout. So that is how your tasks are going to be. So let's try to understand and let's try to see how it is going to work. So for this one, what we have done. So let's look at this part. I have created a table named as this one, right inside this is snow pipe demo. Inside the pipe public, I have created this thing, the raw transactions. Okay. So this is the raw transaction and I will be inserting the mock data, right, inside this one. Okay. Then I have another table, which is the filtered transaction. So this task scheduling, you can try to imagine in the Mendelian architecture pattern. So this raw transaction table will be having your raw data, or you can consider it like a bronze table. And based on some processing, some data cleaning, cleansing, filtering, and intermediate transformation, we will be putting some data in the filter transaction table, and after that we will be creating a aggregated transaction table which will be our gold table. Okay, so in total, just for the task scheduling demonstration, we will be having three tables in total: raw transactions, filtered transactions, and the aggregated transactions. So raw transactions will be having this mock data, and simply using the insert command we will be inserting the data into this one. Now, let me show you that how we are creating the task and what is the syntax for it and how we are simply scheduling that. Let's quickly look into this part. So whenever you talk about the task scheduling or anything, and if you want to simply compare it with the tasks we were creating in the Databricks, so it was pretty much straightforward. We were creating a task, we were giving the information like which notebook should get executed, and then we were mentioning the cron expression, the frequency, like how frequently maybe this particular task or a job should get executed. Also, we were attaching the cluster because a task should get executed, right? So that task will run on some specific cluster. Either on runtime it should create it, or if there is already created one, we want to use it during the execution, that should be used. Okay, so same thing here, create or replace task, and the task is filtered transaction task. And here we are mentioning warehouse, correct? So warehouse means during the execution of this task, which warehouse should be used for the computation. So as I said, we already had our compute underscore WH warehouse created. So warehouse, we are mentioning that one. And after this, we were mentioning the schedule, means the frequency. So after every 1 minute, this particular task will get executed. And what this particular task is supposed to be, like what this particular task is supposed to done here. So we are simply running a merge query. Like we are simply running this merge query with this help of task, right? So running a merge query, it simply we created it and we have scheduled it to run after every 1 minute. So what we are doing here, let's look into it. We want to merge into the filtered transaction table using using the raw table. So in the raw table, what we are doing, if you look at it, we have the pending, completed, cancelled, and for the refund as well. So from the source raw table, we are simply fetching those kind of transactions which were completed or the refunded, not the pending, cancelled, etc., etc. So we are simply trying to keep the filtered one. So why we are running the merge query? It is just like if there is a transaction, right? So based on the transaction ID, right, we are trying to filter the completed and the refund. So in the filtered transaction table, we are simply updating it. If there is a match found on the transaction ID, so simply update all its attributes or update the entire row data in the filtered transaction table. That is what we are doing based on the transaction ID. So here, when matched means the transaction ID is matching. So in that case, we are simply updating the values in the filter transaction in the filtered transaction table. This is going to be the target table, and this is going to be the source table for this particular merge query. So very straightforward merge query. If match has been found, then from the source table, just update the value in the target table. And if there is no match found, just insert that particular record from the source table in the target table, which is our filtered transaction. So in this way, after completing this particular task, right, this will run every 1 minute and it will simply filter those tasks and will simply dump it into the target table. But the point here to understand is every time when it is running, right? So don't consider it like it is going to read the incremental data. That is the point here to understand, because it's just a simple task. In your task, you have simply mentioned the merge query, right? You have simply mentioned the merge query, and this is how it is working. So when you talk about the merge query, which is, let's say, getting executed, right? So it is referring to your target table and the source table. So when you are running this select star something something, you can see we are not picking any newly created record. It's just your simple, what I should say, it's just your simple uh, task you have created, which is running the merge query. So it will point to the entire data. It's not like a dynamic table in Snowflake. It's not like a delta table. That's a simple task. You are running this logic. In this logic, every time after 1 minute, this task will get executed. It will read all the data from the raw transaction table, will filter out completed and refunded record, and will dump into the filtered transaction table, right? If match is found and match is not found based on that condition. Because here the idea is to show you the lineage between the tasks and how the tasks are running. But if your focus is to process the incremental data every time with the help of task, then you have to handle that logic in your query itself. In that case, maybe you can have some is processed or the timestamp based column in your filter transaction table, in your raw transaction table, and based on that one, you can keep a track that from the raw transaction table till which timestamp you have consumed the data. So you basically need to consume the data after that timestamp in the next one. So that kind of delta data, like that kind of uh, delta data extraction, you have to do from your side based on the timestamp related queries, right? So that is how it will be. And for rest of the things, right, as I said, doing the incremental data load processing, we will be like tomorrow with the help of project, we will be looking at the dynamic tables in Snowflake that will clarify this thing, how you can achieve that incremental load. So here we did that. So we created this task which is scheduled for 1 minute. Now what we are doing, we are simply creating the next task, which is this one, aggregated transaction task, warehouse this one. And here we are setting up the dependency. So this task should only get executed after this particular task, which we have created here, is succeeded. Okay. And how this will be running? this will also run a merge query on the aggregated transaction table. So in the aggregated transaction table, what we are doing, again, we are running the update query. So in the target table, using for this merge query, the source is going to be the filter transaction table. So here, whatever data is present in the table after this task execution, whatever data is available in this particular table, it will run the group by query on the transaction date and will take account of the completed transactions and the refunded transaction, and will simply update this entire data again in the aggregated transaction table. So that is what we are doing here in this second task. But the main idea and the main purpose was to show you that how we are setting up that kind of lineage, that dependency. So this task is actually going to depend on this one. So you will create this task, and after that you can simply run it. You can create this first task and you can create this second task. Okay. So when you talk about the scheduled task specifically, so scheduled task is something or any task which you are creating, right? By default, they will be in the suspended state, right? By default, whenever you are like running it. So what I'm going to do here, I'm going to run this show tasks, right? In this database, how many tasks are available. So you will see these are the two tasks, right? Simply you can run the show tasks, and here you will see that state is suspended, right? So by default, whenever you create a task, right, it will be in the suspended state. So you have to resume it, right? You have to start it. So here you also need to make sure the lineage part here, right? So this is the task which depends on this particular task which we have created. So first you can resume that one, and then you can resume the upstream one, right? So that is the thing I have mentioned here, suspend, right? So you have to maintain that thing as well first. So in the backward direction, like based on the dependency and lineage, first you will start the downstreams, right? If they are simply dependent on upstream task, they are not scheduled one. So first you will start them, and then you will simply start the upstream ones. And when you are suspending the task, so first you will suspend the upstream task, then the downstream task. And why Snowflake is doing it? So Snowflake follow this strict rule so that there is no inconsistent processing with respect to the task execution, right? So it should be started in a proper lineage, and the dependency, it should be suspended in that lineage from upstream to downstream, so that none of the execution is hampered. Okay. So that is what we are doing here first. So we will be starting our aggregate transaction task first. So alter task, task name, and resume. So we will resume this one. So it has started. Similarly, now we will start this one as well. So resume filter transaction. Let's do that. This one is also started. And similarly for the suspend part, you can see first I'm suspending the filter transaction because it is scheduled for every 1 minute. And here it is scheduled for this one was dependent on that one. So I'm suspending it after the previous one. Similarly, just to look at the, so now you have scheduled the task, you want to see whether they are running, they are executing something, they are getting triggered on time or not. So for that one, you can check that information from the information schema, like the task history. And by default, right, as I already showed you in each of the, you can say database you create, right, these system tables already gets created, right, related to table tasks, right, and all that. So you can simply get it from here and you can look at the metadata. So here you can see, right, the particular task which is filter transaction task. So let's try to get the information or the history information of all its execution. So far this many time it has been executed. Okay, so if you will look at the execution time stamp or the trigger time stamp, Yeah. So here, if you look at it, right, this is how it was started. This, yeah, 48 first execution, 49, 50, 51, 52, 53, 54, 55, right? And now this one, right? And let me run it one more time. So although it is executing, and you will every time see that it is just, so I will run the table data and will show you that what is the data we have there. Right, so 21, 22, the next schedule time. So the previous, right, so just we started, so it got executed, and here, right, you can see, and after every minute it is running. And let me show you this task as well, which is basically for the aggregated one. So earlier there were only two executions, right? So here schedule time is not going to this one, right? So only three executions of it as of now. Let me run it one more time. So we'll see, apart from three, it will have more. Just give it a moment. Right. So here now for this one, aggregate transaction task, which was actually dependent on this task. So earlier there were only three executions. Now you can see the fourth execution as well. So here it is just giving you all these things, the status. If by any chance this particular task was failed because of any error message, you will get that one. Query start time, query completed one, right? Run ID, right? And all that kind of information you are getting here. And let's look at this part, right? The count. So every 1 minute it is running. So whatever data is there. So my main purpose was to show you that already I have ingested this data, right, in this raw transaction table. So the first merge query which is running, right? The first task we have scheduled for the filter transaction table. So it is running the merge query. So it will every time point to the same table and will keep on putting the duplicate data, and based on that one, the next task which is dependent on the first one is running and running the aggregation queries. Okay, so let me show you the count here, and after every 1 minute we will validate it, the filtered transaction count. So far how many we have? Yeah, so completed. So now you are only seeing four records here, because if you look at this first task we have created, right, in the source table, it will always get matched with the transaction ID. So instead of just let's say we would have removed this update condition, then only the insert will happen, and every time only the duplicate data will get into it. But let's say this data, this transaction ID is already present in the target table. So any updated value or the same duplicate record is present in the source table. So ultimately in the filter transaction table, we are simply writing this thing. Okay. So for this one, what I'm going to do, I'm simply going to ingest few more records. Let's say 10, 11, and 12, right? So if we ingest it, so we will expect few more records now. So I have ingested it. So let me run the count query on the filter transaction. So earlier there were four, now ideally it should be six, whenever this is going to run next after that one. And also whatever data we have in the aggregated transactions. So for this particular date, completed transactions 4, and for this date, completed transactions 2. So I think the data has arrived here. So now you can see total count 6 in this table. And based on that one, every time our merge query is also getting updated in the similar manner, right? So for the particular transaction date, if there is some update on the source table and how we are preparing our source table with this particular group by query. So whatever data this particular group by query will generate, it will be our source data. So for the same date, if we have an entry in the target table, which is this one, so the new aggregations will be updated in the target table. If that aggregation or the aggregation for a date have been created for the first time, it will simply get ingested based on this statement. So here you can see, right, how these tasks were scheduled. So we will see that one tomorrow, that how we are going to utilize all these things together. But for the snow pipe, you have already seen it, that how event driven things were working, how the pipe was running, how based on that stage and all that we were getting the data into the system, right? And similarly, if you have to do these kind of tasks now, like it's all about the SQL. So task could be really, really helpful to perform certain operations which you want to perform on a table, pipe, and whatsoever, time to time, recurring type of operations. So you can simply write it. So this is more of a like creating these stored procedures, the triggers in the databases, which gets triggered based on the insert update and all that. So here it is all about the cron base or the timestamp based trigger. If you want to do certain operation time to time, so based on that one, it can be done. And this is how we can create a task. We can schedule the task here. So the way we have written 1 minute here, instead of writing 1 minute or something, you can write a proper cron expression, and based on that cron expression, it will get triggered. So let me suspend these tasks as well. I don't want them to keep on running. So first I suspended the upstream one, and then I'm just suspending the downstream one. All right, cool. So yeah, that is pretty much for today. I will keep it for the task part, and tomorrow we will be working on the projects, the dedicated projects on Spark, Airflow, and having the Snowflake together, right? All these kind of projects end to end we will be working, which will give you more clarity about the Snowflake, and most important thing, how to integrate Snowflake in the data engineering pipeline using the authentication libraries, jar files, this and that, and how we can read the data in Spark from the Snowflake table, how we can write it, how to create the connections for the Snowflake in the Airflow, how and what kind of operator to be used and all that. So we will be looking all the whole scenario in the tomorrow's end-to-end project, right? So meanwhile, today's time you can spend just play around the Snowflake, set up your free tier account, and I will be providing these SQL scripts and the data sets. So you can play around it and you can try to set up the Snowpipe and all the connectivity, try to schedule the tasks so that you are familiar with these concepts so that we can work on the projects tomorrow. Okay. Yep, that is pretty much. And if you have any doubt, feel free to raise your hands and I can answer your doubts. If you do not have any doubt, feel free to drop and enjoy your rest of the day and complete this thing. Okay. Cool. Let me see the hand raise. Sumaya.
Yeah, hi Shashank. I just want the one help with respect while I was while I was deleting the Kafka cluster.